Good day, everyone. Okay. So today is the last part. The last part of the chapter 3, logical reasoning, real life problem. Okay. Whenever you see the real life problem, right? You are knowing that you should know that you are reaching the last part of the chapter already. Now, before you watch this video, can make sure you know the concept that you've learned so far in this chapter. All right. So look back, okay, at your notes and the video, and let's dive in right now. So for the real life problem, I'm going to show you two examples here, and we are going to go through this step by step to make sure that you know, right? To make sure that you understand what strategy we take. Okay. So example 1. Okay. The diagram on below there, right, shows that the growth of a cell, which begins with a cell A on the first day, 2 new cells are produced. Every cell will produce 2 other cells on subsequent days. The number of the cells growth is Pt equals to 2 to the power of t, right? Where t is the number of the days, right? T denotes as number of the days. How many new cells will be produced on the 8th day? Okay, that is the first question. Second question, on which day will the number of the cells becomes 2048? Now, how many new cells will be produced on the 8th day? Okay, look at the equation here. Okay, I'm going to copy down the equation. Okay, this is the equation. To the power of t. Now, I know that Pt here is the number of the cells. T here denotes the number of the days, right? So A, okay, look at A here. How many new cells will be produced on the 8th day? So simple, right? So just substitute t equals to 8, okay, because you want to know the 8 days, right? So substitute t equals to 8 into the equations, and you should get your answer. So 2 to the power of 8. So calculator, 256. So this is the answer, 256 cells on the 8th day, right? So look at B. On which day will the number of the new cells become 2048? Now this question is asking for the on which day the number of the cells become this. Okay, again we are referring to this equation. Okay, we are referring to these equations. So I know that 2048 is Pt, right? So 2048 equals to 2 to the power of t. Okay, I don't know the t, and t is exactly the variable that I want to find, right? Because I want to find the number of the day. So you can use your calculator to see, okay, 2 to the power of 1 equals to 2048, right? Okay, 2 to the power of 1. Okay, you can use your calculator, do the try and error. 2 to the power of 11, okay, 2 to the power of 11 equals to 2 to the power of t, right? So t equals to 11. So at the 11th day, okay, at the 11th day, on the 11th day, sorry, the number of the cells will reach 2048. Right? So this is the answer for example 1. Right? Now let's take a look at the example 2. Right? Example 2. Okay, example 2. Table below shows the number of the toy car produced by toy factory in a certain morning. So at 8 a.m. 270 toys car, 9 a.m. 520, 10 a.m. 770 toys car, 11 a.m. 1020 toys car. Alright, so you have to construct a general formula for the number of the toy car produced by the toy factory based on the above table. Now, this is difficult, right? This is, what kind of the argument is this? Can you tell me? What kind of argument? You are going from the specific specific premise into general conclusion, right? Whenever you are deriving a formula, it means that you are constructing a general statement, right? So this is called an inductive argument. Okay, this is called an inductive argument. So first you need to take a look at the number of the toys car. Okay, I'm going to write the sequence down here, example 2, right? So this is the example 2. So this is the sequence that I see here: 270, 520, 770, and 1020. Alright, okay, I need to find the pattern here. So here, 270 equals to what? 520 equals to what? 770 equals to what? 1020 equals to what? Now, over here, you need to be creative. Okay, you need to do a lot of exercise to actually find the idea. Alright, to find the pattern, you need to find the common feature. So let's say I separate 270 into 250 plus 20. Okay, let's say I do this. Alright, and then 520 I can separate it as 500 plus 20, right? 770 I can say 750 plus 20, right? So 1020 I can write as 1000 plus 20, right? So I'm seeing a pattern here. There's a 20 here, right? Okay, the problem here is the first number over here. Now I need to think again, right? Because in the end, I need to have a general formula, so that the definition of n equals to 1, 2, 3, so I must find some way to make 1, 2, 3, 4 appear. Alright? So let's try. Okay, let's try here. Okay, I'm going to further separate this. Okay, factorize this. So 250, let's say there's a 1 here. 250 times 1 plus 20. Right? Because 250 times 1 still equals to 250, right? How about 500? If I take out the 2, because I want the 2 to appear, right? I want the 2 to appear. So let's say I take out the 2. 500, take out the 2. What is left? 250, right? See that? How about 750? Okay, supposedly if my deduction is correct, you should get 3 out here, right? So 750, take out the 3. What is left? 250. Okay, applying the same thing to the fourth equations. 250 again, right? Because 250 times 4 equals to 1000. Now, can you see the pattern here? So the formula, okay, the conclusion or the formula would be what? 250 is the common feature, right? So 250. 1, 2, 3, 4 is changing, right? So n plus 20. So this is the answer. Okay, this is the answer for A, example 2A. 200. The formula for the production of the toy car is 250n plus 20. And the definition of n is 1, 2, 3, and so on. 1, 2, 3, 4, and so on. Alright. So let's take a look at question B. Okay, the toy factory operates from 7 o'clock in the morning until 10 o'clock at night every day for 5 days in a week. How many toys car can be produced by the toy factory in a day? Okay, so now we already have the formula. So the rest should be a piece of cake. Okay, so this is part A. Okay, part B. B1. Right? How many toys car can be produced by the toy factory in a day? So this is the formula, right? This formula, 250n plus 20, can help you to find out the number of the toy cars, right? Okay, the number of the toy cars, right? So take a look at the time here in a day, right? So how many hours? How many hours in a day from 7 o'clock until 10 o'clock at night? 15 hours, right? Okay, 15 hours. So n equals to 15. Okay, because according to the last equation, n here actually means the how many hours, right? At which hour the number of the number of toy cars become what, right? So I'm going to substitute n sub n equals to 15 into the equation, right? So the total number of the toy cars is 250 times 15 plus 20. So take out your calculator, and what is the answer? 3,770 toy cars. So this is the answer for B1. So for a day, right? In one day, 3,770 toy cars will be produced. Now let's take a look at B2. The toy factory received an order of 2,500 toy cars. Okay, this order needs to be completed in a week. Will the toy factory be able to deliver the toy cars on time? If it is not, suggest a solution. Alright, so first we need to think whether what is the how can we do this? Okay, how can we do this? First, let's try to find out in a week how many toy cars can be produced. Alright, so I know that in a day, right, 3,770 toy cars can be produced. So in a week, by right, how many toy cars can be produced? In a week, number of the toy car produced is what? 7, sorry, not 7, because in a week only 5 working days, right? So 5 times 3,770, right? So what is the answer? 18,850. So can it complete the order? Can the factory complete the order? Cannot, right? Cannot complete the order. Cannot complete the order. So suggest a solution so that the toy car can deliver this order, right? So what can you suggest? What can you suggest? So let's take a look at the formula that we just got from part A. Okay, so this is the formula, 250 n plus 20. Okay, take a moment and think. Okay, take this moment and think. This formula actually tells us what? Okay, the formula actually telling us the daily production, right? The daily production of the factory, and this n here constitutes to the number of the hours working daily, right? So what is my expectation? Okay, look at the questions again. The expectation is after 1 week I need to have 25,000 toy cars, right? So this is a day. Okay, a day we have this much of the toy cars. So if I work for 5 days a week, the total number of the toy cars should be this, right? It should be this, 5 days times the daily production. So my expectation is 25,000, right? So by solving this equation, you should be able to find the n. Okay, when you find the n, you are actually finding the daily working hour, daily production hour in order to complete the order, right? So let's try to solve this equation. Okay, move the 5 to the right hand side, which is 5,000. Okay, move the 20 to the right hand side, 4,980. Divide, okay, 4,980 divided by 25, 19.92, right? So, in conclusion, the factory needs to operate for 19.92 hours in order to meet the order, right? But this decimal here is not very good. Okay, when we say hour, we normally means 1 hour, 2 hours, 3 hours, right? So this is not good. So if I want to decide whether I put 19 or 20 as the answer, which one should I choose? Okay, I need to choose 20. Why? Not because of the rounding off, because it must be 20. If you pick 19 as your answer, you are not going to be able to meet the order because you only work for 19 days. But our calculations show that you need to work at least 19.92 hours, right? So 20 hours is the least amount of the hour that you need to do in order to complete the order. Therefore, the solution for the B2, right, is you have to extend the daily production hour to 20 hours. 20 hours a day, right? If you work only 15 hours a day, you cannot produce the 25,000 toy cars, right? So as usual, the assignment will be attached to this video. Okay, make sure you complete them, and ciao.